Hello pre-algebra students, welcome to your video on evaluating expressions, and we're going to do that using the substitution property. So we've heard simplify, we've heard evaluate, but what's the difference? What's the difference between simplify and evaluate? Well, simplify means do all the math that you can do until you can't do any more using the order of operations. So simplifying an expression would be taking something like 3 squared minus 2 times 4 and doing the math, 9 minus 2 times 4, 9 minus 8, which is 1. We've simplified it. We can't do any more math. Or when we get to an algebraic expression, x plus x, we simplify that by making it 2x. So simplify means do the math you're allowed to do until you can't do any more. Evaluate means plug in replacement values for variables. And we talked about variables in our previous video. And then you're going to simplify to find the numerical value of the expression that we're talking about. So when we say evaluate, that means something a bit different. So let's look at the substitution property and let's look at an example of evaluating an expression. The substitution property of equality states that if A equals B, then one can replace the other in an algebraic expression. So if I have a situation where I'm told, I'm given this rule, like right here, x is equal to -7. If x is equal to -7, then I can use -7 to replace x in any expression. Let's take this one right here. 3x plus 9. Well, I'm going to take my expression, and I'm actually going to substitute the -7 for the x. And then I do the math, and I get my answer. So we're substituting one value for another because they are equal. So, generally, how do we evaluate expressions? Well, step 1, copy the expression and the given replacement value. So whatever the expression is that you get, copy it down and write down what x and y or a and b, etc. Write down what they represent. Or excuse me, what the value of them happens to be. Then you're going to rewrite the expression, replacing the variables with the given values that you have. And you're going to put those values in parentheses when it's necessary. And we'll look at several examples so you can start to understand where you have to and where you don't. You're going to use the order of operations then to find the value of the expression. So you will go down all the way to a numerical answer in the end. Let's look at some examples here. So there you have the 3 replacement values for the variables. X is equal to -3, y is equal to 4, and z is equal to -5. So basically what we end up doing next is we take the expression that you're given, and this one is x plus y plus z, and in the place of x and y and z, I'm going to write my numbers. Now in this expression, note that I put parentheses around the -5, but I didn't put them around the -3. I don't really need parentheses around that -3 because there's nothing in front of the -3 that I could confuse with the minus sign or the negative sign on that 3. I didn't need to put parentheses around the 4 because it's positive, but here I did put parentheses around that -5 because when we say plus -5, we want to go ahead and see the parentheses to protect us from getting confused about those two symbols. Now, from here, we're just going to add it the way that we learned in class. And I did have someone tell me in class that why don't we add the negatives together first? So add those two numbers first, which is -8. And then go ahead and add them. So the value of this expression ends up being -4. And we only added the negative values first because negative plus negative is same sign, add and keep. So that's a little easier. And then I added the 4 to finish it off. How about the next one? X minus y. So x is -3 minus a y of 4. And that is an expression that where we use keep, switch, switch. So we can see that that's -7. Okay, if you feel like you're catching on to this too quickly, pause it and try these yourselves. Excuse me, pause these and try it yourself. But I'm going to go ahead and keep on working. Y plus 2z. Y is 4 plus 2 times z is -5. So 4 plus -10 simplifies to -4. Remember for me that it said on that previous slide that you should be writing this down. If you haven't written this in your notes yet, write this down for me because you're going to need that information, and it is very common to plug the wrong number in for a variable. So please make sure you write that down. Okay? And then this last one, we've got x times the quantity, y plus z. And when I say the quantity, that means I'm trying to keep the y plus z together, and that's what I use parentheses for. So we have -3 times the quantity 4 plus -5. And yes, it's okay to have parentheses inside parentheses. Let's just do the math we see and finish the problem. So 4 plus -5. I haven't used my -3 yet. 4 plus -5 is -1. -3 times -1 is +3. All right. Another type of expression with the exponents. I want to go over this difference. There is a big difference between x squared and -x squared. They are not equivalent to each other. Well, you're like, duh, because there's a negative sign there. But I'm not just talking about what we see right here. I'm also talking about what we have when we plug in a variable. So let's do this a couple of different times, okay? So I want to do it first where x is equal to 4. And then I want to do it again where x is equal to -4. When I plug in a value for a variable and it's got an exponent, I should put it in parentheses. X squared means x times itself. So this is 4 times 4, and that's 16. This expression, this next expression, this one right here, is different. I'll put my 4 in for x, but the negative sign goes on the outside of the parentheses. Because the way this expression works right here is that the exponent applies first, the negative sign applies second. So I'm going to square my 4 first and get 16, and then I'm going to turn it negative by applying the negative sign that's out front. So as you can see, x squared came out to be +16, and -x squared came out to be -16. Let's try it where we plug in -4. The parentheses are very important here because they make a big difference between the two expressions. If we didn't have the parentheses with this exponent, it makes a big difference. So again, anytime you're plugging in that number for the variable with an exponent on it, you got to use parentheses. So let's again, oops, sorry about that. I apologize for the loud noise. That was my iPad flopping down onto the counter here. Remember what x squared means. It means x times itself. So if x is -4, it's -4 times -4, which is +16. Again, same idea over here. Plug in your -4 in parentheses, put the rest of the expression around it. Once again, -4 times -4 is +16. And the negatives out front makes it -16. So it's funny, these two expressions have a big difference between each other, 16 and -16. And remember, there is a big difference between positive and negative. We want to remember that's the difference between a deposit and a withdrawal. And I think you would really care if the bank made a mistake, one to the other. Of course, you'd be really happy if they considered a withdrawal a deposit, but you wouldn't be so happy if they took a deposit and thought of it as a withdrawal. So these two expressions are very different from each other. But look how plugging in a different value, very different, positive to negative, still yielded the same result for x squared and the same result for -x squared. So it's all a question of what do I apply when. X squared means x, the value times itself. -x squared means the value times itself. Tack a negative sign on afterwards. Let's put this into action with a couple more expressions to evaluate before we finish this video. All right, and once again, I need my image with the values for, let's see, for x, y, and z. Okay, so I've got my x, y, and my z again. All right, z plus y squared. Okay, and again, hey, if you're feeling comfortable, let's change colors. I haven't changed colors in a while. Let's use purple. If you're feeling comfortable, go ahead and pause it and try these yourself, and then you can watch it again and see how we did. All right, z. Do I need parentheses for that? Does it change anything if I have them? It really doesn't. So you can actually just err on the side of always putting parentheses on them. So z plus y squared. So y squared in this case is 4 squared. That's 16. And z is negative 5. So negative 5 plus 16, 11. How about this one? Y squared times z. Well, in this expression, this is multiplication. That's like saying y squared times z with a dot, but you don't need the dot. Okay, so when I plug these numbers in, I'm going to start off with it looking like this. So it's like I have one of those puzzles for little kids with the big puzzle pieces. You just drop the pieces right in. You can already see where they go. Think of this as you're just dropping your numbers right in. So you're taking your y value and dropping it right here, 4. You're taking your z value, negative 5, and you're dropping it right here, negative 5. And now we're going to do the math in the order that we use order of operations. So exponent first, multiply afterwards, negative 80. Last one, x cubed plus y squared plus z. Plug your numbers in. Negative 3 for x, 4 for y, negative 5 for z. Negative 3 cubed, let's think about it, is negative 3 times negative 3 times negative 3. That means negative 3 times negative 3, which is 9, times negative 3, which is negative 27. Plus 4 squared, we've been using that one a lot today, that's 16, plus 5. Just like we added the negatives first on that first slide, why don't we add our positives first this time? Add my 2 positives, I get 21. So now I have negative 27 plus 21, which comes out to be negative 6. So we have learned how to evaluate these expressions. So once we learn how to do more with expressions, we'll start working our way into some more algebra, some more serious algebra. But don't worry, because you know Miss LeCompte, I'm going to make sure we take our time and we understand what we're doing. Hope you enjoyed it. Hope you're having a great weekend, and I will see you guys in class.